Hi guys, welcome to our calculus tutorial. I'm Paxton and my teammates Harish and Alex. Today we are going to explain about the intersection and system of two lines in 2 space and 3 space. Intersection of lines defined as more than one line, passing or lying across each other. Lines perform differently and have different system in 2 space and 3 space. So, what is a system? A system can be categorized into consistent and inconsistent system. A consistent system means that the system has one solution or infinite solutions. For an inconsistent system, the system has no solution. Next, let's go into detail about lines in 2 space and 3 space. Lines in 2 space. In 2 space, there are 3 cases for the intersection of 2 lines. Case 1. 2 lines intersect at one point. If 2 lines intersect at one point, which is point P that we assume, this point P is the solution of 2 lines, and the system is consistent system. Case 2. 2 lines parallel and distinct. If 2 lines are distinct, it means that they don't share any common point, even though they are parallel to each other. The system in this case is an inconsistent system. Case 3. 2 lines are parallel and coincident. If 2 lines are coincident, it indicates that they share every point on the lines, because the 2 lines are overlapping. It has infinite solutions and the system is consistent. Lines in 3 space. In 3 space, there are 4 cases for the intersection of 2 lines. The first 3 cases are similar with 2 space. They are 2 lines intersect at one point, 2 lines parallel and distinct, and 2 lines parallel and coincident. As we mentioned them before, we will just briefly and quickly talk about it. The first case is 2 lines intersect at one point. It has one solution and system is consistent. The second case is 2 lines parallel and distinct. It has no solution and system is inconsistent. The third case is 2 lines parallel and coincident. It has infinite solutions and system is consistent. The fourth case is skew. If 2 lines are skewed lines, it means that they don't intersect and parallel to each other. In this case, no solution can be found, so it is an inconsistent system. Now you know how to classify lines in 2 space and 3 space. Let's have a look to our first question to know how to solve the system. Firstly, we need to check the direction vectors m1 and m2. Since 1 over 2 it does not equal 2 over 2 does not equal 3 over 1. So they are not parallel. They can be either intersecting at a point or skew. To have a clear vision of the equations, we can change the vector equation into parametric form. For line 1, it is followed as, and for line 2 is next. Let's assume the 2 lines intersect at a point x, y, z. In this case, we can equalize the lines because they have same x, y, and z values. Next, we simplify the equations. Now we use the elimination method to find out the values of s and t. Elimination is a process of removing another variable in order to find the specific variable. In this case, we would like to choose equation 1 and 2 to eliminate t due to it's easier to be solved. Firstly, eliminate t value to get s by using subtraction. We subtract and now we got the s value, which is -3. Then we substitute s value into equation 1 to get the value of t, which is -3. Now we have the values of s and t. After that, substitute the values of s and t into equation 3 in order to check their consistency. Since negative 6 does not equal to negative 3, this is a false statement. In other words, we call contradiction, which indicates that the lines do not intersect each other. Since the lines are neither parallel nor intersect, that means both of the lines are considered as skew. As a system does not have any solution, it's considered as inconsistent system. Yes, that's how to solve this system, and we did it. Yay! Wait, the text is not over yet. In order to describe the system of lines is consistent, we will use one more example to figure it out. Question 2. As we explained in question 1 before, we need to check the direction vectors first, which is 2 over negative 2, 1 over 1, and negative 5 over negative 5. They do not have the same ratio, so these two lines are not parallel, so it can be either intersecting at a point or skew. Same as question 1. Let's change the vector equations into parametric form. Assume the lines intersect. We equalize the equations of the lines. After simplifying the equations, we get, here we use elimination method again. We can choose equation 1 and 3. We eliminate t to get s value. Then substitute s equals 0 into equation 3 to obtain t value. We substitute both s and t values into equation 2 to check the consistency. Since the answers are equal, it indicates that line 1 and line 2 intersect at a point. So there is one solution, and system is consistent. In order to find the point of intersection, substitute s and t into any of the two lines. Let's substitute the values into the equation of line 1. Therefore, the point of intersection is 2, 4, 2.
Guys, after a long boring section, now it's time to gain a little knowledge. Do you know how many dimensions do we have in our universe? 7, 256, or even 1000? Well, actually, there is still no definite answer yet. Scientists have proposed many theories, but none of them is proven yet. One of the theories is the superstring theory, in which 10 dimensions are believed to exist. In our calculus lesson, we learned about first, second and third dimension only. However, how many of you know about the fourth dimension, which is about the time? This is the dimensions in where the time travel exists. And the fifth dimension would be the two possible worlds exist in one dimension. On the other hand, the sixth dimension is a plane of all possible worlds with the same start conditions. The seventh dimension is a plane of all possible worlds with different starting conditions. Now, the eighth dimension is a plane of all possible worlds with an infinite start conditions as shown in the figure. The ninth dimension would be the all possible worlds with all possible start conditions and laws of physics. Now, this is the final interesting part. How about the 10th dimensions? Can anyone guess? This dimensions is an infinite possibilities, and maybe the creator of the universe lives here.